You're standing at the cutting board. The knife comes down. And within seconds, your eyes are burning. You didn't get hurt. Nothing touched your face. But your body is reacting like it's under attack. The real answer is far stranger than you think. This isn't sadness. It isn't even really about your eyes. It's a chemical weapon, built by a vegetable, aimed directly at your nervous system. Onions did not evolve to make dinner easier. They evolved to survive. Every living thing on Earth has some way of defending itself. Animals run. Animals bite. Plants can't do either of those things. So plants had to get creative. Over millions of years, some plants developed something even better than teeth or claws. They developed chemistry. The onion is one of the best examples of this on the planet. Inside an onion's cells, there are two ingredients that are normally kept completely separate. One is a sulfur-based compound called amino acid sulfoxides. The other is an enzyme called alliinase. As long as the onion cells stay intact, these two substances never touch. They sit in different compartments, like chemicals in two sealed rooms. Then you bring a knife down. The moment you slice through an onion, you rupture thousands of its cells at once. And when those cell walls break, the wall between the two rooms disappears. The enzyme and the sulfur compound mix. And that reaction creates something new. A sharp, unstable gas. Here's where it gets interesting. Scientists actually didn't understand the final step of this reaction for decades. Everyone assumed the gas that irritates your eyes was created in one simple step. But in 2002, a team of researchers in Japan, led by biochemist Shinsuke Imai, discovered something that had been hiding in plain sight. There was a second enzyme involved. One that nobody had identified before. They named it lacrimatory factor synthase. Its entire job, its only purpose, is to take that unstable gas and convert it into the specific compound that makes you cry. That compound has a name. Syn-propanethial S-oxide. It sounds like something from a chemistry exam, so let's translate it into plain English. It's a gas. It's volatile. And the moment it forms, it drifts upward, off the cutting board, into the air around your face. Why your face, specifically? Because that gas is small enough, and reactive enough, to combine with the natural moisture sitting on the surface of your eyes. When it touches that moisture, it doesn't just sit there. It reacts again, forming a diluted version of sulfuric acid, right on the surface of your eyeball. Your eyes are not being dramatic. They are being chemically attacked, in real time, by a compound your dinner just released into the air. So your body responds the only way it knows how. Your eyes have specialized nerve endings, called the trigeminal nerve, that exist specifically to detect irritation and pain on the surface of the eye. The moment that mild acid touches your eye, the trigeminal nerve fires an alarm straight to your brain. And your brain responds instantly, without asking permission from you. It floods your eyes with tears, trying to wash the irritant away before it can cause real damage. You're not crying because you're sad. You're crying because your eyes are trying to protect themselves. This has nothing to do with emotion. It's pure biological defense. Here's the twist most people never learn. This entire chemical weapon only exists because the onion got cut. An intact onion, sitting whole on your counter, is not releasing any of this gas. The compound only forms the instant the plant's cells are physically destroyed. Which means the very act of preparing your dinner is what triggers the attack. Evolution built this system for one reason. To stop things from eating the onion in the first place. Insects, rodents, grazing animals, all of them would be discouraged by a plant that fights back the second you bite into it. A burning, acid-forming gas is a very effective way to make sure whatever's eating you stops eating you. Humans just happen to have bigger brains, and steadier hands, and a much higher tolerance for temporary discomfort in exchange for flavor. Scientists studying the broader allium family, which includes onions, garlic, and shallots, have found that this same defensive strategy shows up across almost the entire group. Chemist Eric Bloch spent decades studying the sulfur chemistry of these plants, and his research helped map out just how sophisticated this defense system really is. Different species of allium produce slightly different sulfur compounds, tuned to slightly different threats. Garlic's compounds are famous for their smell instead of their sting. Onions specialize almost entirely in irritating your eyes. Every plant in this family made a version of the same evolutionary bet. Make yourself difficult enough to eat, and something else will leave you alone. So what can you actually do about it? Once you understand the mechanism, the solutions start to make sense instantly. Cold onions release the gas more slowly, because lower temperatures slow down the enzyme reaction. That's why some people chill their onions before cutting them. Cutting near a fan, or cutting under running water, works because you're either blowing the gas away before it reaches your eyes, or dissolving it in water before it can reach your face. And sharper knives genuinely help, because a sharp blade ruptures fewer cells overall. A dull knife crushes and tears far more of the onion structure, releasing significantly more gas into the air. None of these tricks are old wives' tales. Every single one of them works because it interrupts a specific, well-documented step in the chemistry. There's something worth sitting with here. You've probably cut hundreds of onions in your life. Maybe thousands. And every single time, without knowing it, you were triggering a defense system that took millions of years to perfect. A plant with no muscles, no brain, and no ability to move, found a way to make you cry using nothing but chemistry. You walked into your kitchen expecting to make dinner. Instead, you set off an alarm system built to keep you away. And your body, without asking, is already trying to protect you from something you can't even see.